Hey there. Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.
Hi, today in my bench I have the Samsung home theater DVD. Now the owner of this unit, and he is a customer of mine, he told me that he was using it and it was working normally, but suddenly it stopped working and it turns off by itself. So when he tried to power it on again using the power button in the unit, the display in it works for almost 2 seconds and then it turns itself off. So today in this video we are going to take a look at this unit in order so we can see what's wrong with it and how we are going to repair it. Let's get started. Now before I tear down this unit and open it up, I'm going to power it on just so I can see what it is doing. So let me just plug in the power, and here's the power cord has been plugged in. And the cool thing that I noticed that there is no push type buttons in the unit. It has the touch type buttons. That is really cool. So yeah. So here is the power button in the unit, and if I just push it, we can see that the display in it display hello, and the DVD it works and it turns itself off. And if I just power it on again, it display the same thing, but it get and display protect. Wow, that is interesting. The customer never said that it displayed protect. So this tells me that there is some kind of a short inside of the unit. So let me unplug it and remove the cover and take a look inside. So here's the cover has been removed, and in order you can remove the cover, there is 2 screws from this side and from the other side and 3 on the back. And once you remove them, you can remove the cover. Now the cover metal, it is very thin and it is about a half or a 0.8 millimeter in thickness. So yeah. Now let me just put the cover aside and take a look inside. Now if we take a look at the inside of the unit, we can see that this unit, it is not something cheap, and it has a really nice build quality in it. Now in here we have the power supply, and we can see that there is a 2 chopper transformer. My guess is that because this thing it is a home theater, this means that it has a power amplifier built in, and we can see from the chokes and the heatsink that this is where the power amplifier chips it is installed. So yeah. Now taking a look at the power supply section, we can see that there is a chopper transistor and 2 chopper transformers and 2 diodes. So yeah, and I guess they are diodes. Let me just zoom in a little bit in order so we can see better. Oh yeah, 2 rectifier diodes. So yeah. This thing, it has a really nice build quality. Wow, really nice. Now the first thing that I'm going to do, I'm going to try to find the schematic of this unit, and then we will proceed from there. So I search for a model number in order so I can get a schematic for this unit, and it turns out that the model number, it is printed in the label in the bottom of the unit. And according to this, the model number that this unit has, it is the ht-c455. Now, after some search, I was able to download a copy of the manual for this model, and as we can see, here is the manual that I downloaded it. They call it a digital home cinema system, and it is for the model ht-c455. Now, taking a look at this image over here, and if we zoom in a little bit, we can see that this model or this unit, it is designed to be connected to 4 speakers, and it has a central speaker and a woofer built in the same box. And also this unit, it is designed to be connected to a projector unit. Wow, this unit, it is really interesting. Now, if we scroll down a little bit, we can see that this manual, it has the specs, and it has the disassembly information, and also it has the troubleshooting section, and also it has a wiring diagram and a complete schematic for the entire set. So this manual, it is very, very useful. Now, if we scroll down a little bit to the section that the troubleshooting, it is existed in it, and here is the pictures of for the disassembling process. Now, if we remember, when we power on the unit, it display protect, and this is a really interesting clue, and this will help us to diagnose the malfunction according to the troubleshooting that this manual it is providing. So let me just continue the examination for this manual, and then we will examine the troubleshooting section. So here's the troubleshooting in the manual, and it describes every kind of symptoms individually. For instance, here is the main power failure. This is when the unit, it doesn't power on at all, and here is all of the steps that you need to check in order so you can power on the unit. But we don't care about that. We care about the protection symptom, and here is the sound. Now, the interesting thing that this manual, it shows and it describes the every circuit that this unit have individually, and it only connected it to the other circuit using marks and pin numbers. So yeah, so the manual or the schematic, it is not a complete manual. It is only a circuit, and it is connected to the other one. So yeah, as we can see, but still a very handy manual. Now in here we have the video out. We don't care about that. Here is the composite out, or the composite. Here is the HDMI circuitry, and here is the measurement that you need to take when the protection circuit it is operates. Now a SMPS problem will cause this issue, and also a power amplifier will cause this issue as well. And here is the measurement that you can perform by yourself in order so you can see if there is a problem in the power amplifier circuitry or not. Now, as we can see in here, with the help of a VOM meter, you can check the resistance between the terminals and the ground or the body of the unit. And here is the value you should get. With this model, the C450, and it is close to the 455, you should get at least a 1.8 ohm. So yeah. So I'm going to connect my VOM meter to the unit, and then we will see what happens. So here's the VOM meter connected, and according to the manual, we should inspect the pins on these jacks. So here is the front and the rear jacks, and here is the front and the rear jacks, the left and right, and here is the central, and here is the subwoofer jack. So between this and the ground, we are getting around 1 ohm. That is normal. Between this pin and the ground, and because it is reversed, we can see that we have 1 ohm, so it is identical to this one. In here we have this pin, and it is also 1 ohm, and it is identical to these two. And in this pin we have the 1 ohm as well. And in this jack we also have 1 ohm, and it is the same like all of these. And in this we also have 1 ohm. So the problem, and according to the schematic, it is obviously not in the power amplifier section. So the next step, I'm going to power on the unit, and we will check the voltages in the power supply, and then we will go from there. Now, the good thing about the power supply that all of the voltages pins are labeled. So in here we have the minus 5 volt. The above it we have a 5.4, and the next pin it is a 5.4, and also the pin 12 it is a 5.4. Then the next two pins, they are ground, and the next pins, they are plus 12 volt. As for the other pins, they are labeled ground, power on, and this is for from the CPU of the unit, and then the VFD voltages, the minus and the positive, and after that we have the minus VP, and then the ground. The pin 1, it is ground. So what I'm going to do, and because I only have 2 hands, I'm going to connect this wire into this pin like so, and it is connected to this alligator clip, and we are going to power on the unit and view the meter and see what kind of voltages we are going to get when we power on the unit. So in this pin we should have, and according to the labeling, we should have a minus 5 volt or a minus 12 volt. That depends on the regulator circuit that this section of the unit it is or this section of the power supply it is providing. So here's the unit has been powered on. Here you go, and we have 0. Yes, we have 0.200. So yeah, this is very wrong. So yeah, let us power it again, just so we can see. Yes, it is about a 20 millivolt. That is very, very wrong. So let me check the other voltage or the next pin, and this is the 5.4. As we can see, it is 5.38, and that is very, very close, and that is really good voltage. So yeah, let me check the other voltage, and that is in the pin 9. It is should be 12 volt. Here we go. Let's power on the unit. We have 10.5, 10.8, and then it goes to 0. So either there is a problem in these two voltages in the power supply, or there is a short in this main board. So how we check this, we are going to take a look at the schematic, and then we will proceed from there. Now, taking a look at the schematic, and here's the power supply section. As we can see, it is completely detailed. And here's the pin that we did the test on. Here's the pin 15 from the jack, and it is for the minus 5 volt, and it is for the model 550. The minus 12 volt, it is for the 5500, and it is coming from a regulator IC, and it is the 7905, and it is controlled from this pin, and it is the power on pin. And the power on pin, it control and it feeds the power to this transistor, and this transistor, it will control the gate of this NPN transistor, and it is connected in this way. And this NPN transistor, it gives power from these two resistors in series, and they are rated for 10 ohm each. And then it came from this diode, and then from the transformer. So yeah, the other voltage, and it is the plus 12 volt. It came from this MOSFET through this choke. And my guess is that the 12 volt, it doesn't have any kind of problem in it, but because the voltage, the minus 5 volt, it is missing, it also affect the positive 12 volts. So yeah. So what I'm going to do, I will try to search the schematic where the minus 5 volt it is connected to and what it feeds, and then we will take a look at that circuit. So after a lot of searching on the schematic, it turns out that the minus 5 volt it is directly connected to these two ICs, and these two ICs, they what drive the power amplifier chips, and the main voltage for these two ICs is the minus 5 volt and the plus 5 volt. And if we take a look at the schematic or the wiring of this circuit, we can see that the plus 5 volt it came from the power supply, directly goes to a resistor, and this is a 4.7 ohm. It is a tenth of a watt, and the minus 5 volt, it goes to the same type of resistor, and it is also a tenth of a watt, and then directly goes to the IC pins. Now this IC, and according to the datasheet of it, it has a built-in protection circuitry, and whenever there is a problem in the output or there is a problem in one of the voltages, the protection circuit in it it trips and it sends a signal to the processor, and the processor, it shut the power supply. So yeah. So what I'm going to do now, I'm going to disconnect the power cable, this guy over here, and then I'm going to check the resistance of the minus and plus 5 volt rails with the help of the digital multimeter, and we will go from there. So here is the digital multimeter has been connected and has been set to ohms. And I'm going to check the positive 5 volt, and it is this pin over here, and here we go. And if we take a look at the digital multimeter, we can see that it is giving a reading up to 3.2 kilo ohm. That is really good. As for the minus, we can check the resistor, or we can check the pin itself. There is no problem. Here we go. Here is the pin, and as we can see, it is much more higher value, but that is completely normal because the 5 volt or the 5 volt plus the plus 5 volt rail, it feeds a lot of circuits. So yeah. So this tells me that there is no problem in these two ICs, and the problem, it is probably in the power supply section. So what I'm going to do now, I'm going to remove the power supply from its place, and then we will check all of the circuitry of it, and we hope for the best. So here's the PC board of the power supply has been removed from its place, and here is the plastic cover of it has been also removed. And the cool thing about this plastic cover, that the power supply PCB, it is held to the plastic cover with these hinges. That is really nice. So anyway, back on the power supply PC board, if we examine all of these components, nothing looked to be blown or burned, and that is nice. But if we flip the board to the other side, and if we examine it, we can see that there is a problem in this area over here. Now if we just zoom in a little bit, we can see that there is two resistors. They are completely burned out, and they are connected between the output of this rectifier diode and the transistor that feed the power to the transistor that control the IC, or the minus 5 volt regulator IC. These two resistors, they are completely burned up and they are gone, as we can see. So what I'm going to do, I'm going to remove all of these components and check them individually, and then we will go from there. So I tested all of the component in the positive 12 volt rails and in the minus 5 volt rails, and all of the component in the positive 12 volt rails, they tested good and they will perform in a really good way. But the negative 5 volt rails, all of the component in that rail, they were faulty. I mean, starting with the main filter capacitor in that or in this line, to the switch transistor, to the IC, and to the output filter capacitor. So what I did, I replaced all of these for component. As for the resistor, I replaced the two resistors, and once again they are rated for 10 ohm each at a tenth of a watt. I replaced them with a quarter watt 10 ohm pin type resistors, and I heat shrink these two resistors after I connect them and solder them in series. Now I could go ahead and install the original resistors and held them to the PCB with some epoxy or with some resin, but this is much more current handling from the original design. Now, as for the faulty component, these two capacitors, when I tested them using the capacitor meter, this one was low in value, but this one was shorted internally. As for the regulator IC, when I tested it using the bench power supply, it tested good and it produced the correct voltage, but when I started to draw current from it, it shorted internally. That is really, really weird. I never seen an IC that it will act like this. As for the switch transistor, the transistor was faulty as well. So I went ahead and replaced all of these components with a Korean made component, and this is the new IC. I didn't have the plastic type IC, I have the metal type, but I heat shrunk the body of the IC, as you can see. As for the switch transistor, I installed the BD139 instead of the original transistor, and the BD139, it can work in a really good way in this circuit because it can handle up to 1.5 amp. As for the two filter capacitors, this is the main filter capacitor and this is the output filter capacitor. They are both installed from a original brand. So I believe the power supply now, it is working perfectly. What I'm going to do now, I'm going to hook some power to this power supply and we will see how the voltages are going to be produced by it. So I connected my test power cable to the AC input of the power supply, and as we can see, I already connected my DMM leads to the negative 5 volt rails. And now we are going to power on the unit and we will see what this power supply it is going to produce. As we can see, here's the power, it is on. And if we examine or if we shorted the collector and the emitter of the switch transistor that feed the power to the minus 5 volt regulator IC, as we can see, here is the 5 volts, 4.94 as we can see. So this is a really good voltage, and this tells me that the minus 5 volts it is now fully operational. The next step, I'm going to install this power supply back into its place in the unit, and then we will power on the unit and we will see what will happen. So here's the power supply has been installed back into its place in the unit, and now we are going to plug in the power and we will see how this unit it is going to behave. So here's the power has been plugged in and let's turn it on. And as we can see, the unit, it is obviously working. No disk. That is really good. Let me check if there is any kind of abnormal temperature. Everything seems okay. So let me get a CD, and then we will see if the CD will, the CD driver will read a CD. So here's the CD, and let me just open the door. Here's the door tray. It is now open, and let's see if the CD mechanism, it is going to take the CD or read it. And as we can see, that CD, it is now playing by the unit. So the next step, I'm going to connect a speaker to one of the speaker terminals of the unit, and we will see what this unit is going to sound like. So I connected the speaker to one of the speaker terminals of the unit, and now we are going to power it on, and we will see what will happen. So here's the power, it is now on. And the unit, it is started to load the disk. And let me just boost up the volume. As we can see, obviously this unit, or the amplifier in this unit, it is now working. Let me pause this video and select another speaker output terminals, and we will see what this terminal, it is going to sound like. So here's another terminal or another speaker output, and as we can see, this is also working like it should be. Now let's switch to the other one. And here's the left speaker output, and if we just boost up the volume, we can see that it also sounds really good. So obviously the power amplifier in this unit, it is working like it should be, and also the DVD driver, it is also working like it should be. All what I have to do now, I'm going to put the back cover back in and secure it with its holding screws, and my work here, it is done. So I hope in the end that you enjoyed this video. If you did, please like, subscribe. Thank you for watching. See you next time.